right, folks, we have arrived at the end of things. Let's break this down. This looks like a beast. So things I take note of, right? I have a quartic on the numerator, and maybe it looks initially like the degree in the numerator is larger than the degree in the denominator, but it's not, because this is x squared squared. So essentially on this denominator, I have x squared squared, right, which is x times x to the fourth, which is x to the fifth. So I do have a quintic down here on the denominator. So the degree in the numerator is less than the degree in the denominator. I can see I have a linear factor here. I have an irreducible quadratic factor because x squared plus 1 is a sum of squares. All right, and then on top of it, that irreducible quadratic factor is repeated. So let me go ahead and erase my little scratch work here, and I'm going to start to set up my partial fractions. So I'm going to need a fraction for my linear factor. I'm going to need a fraction for the first degree, or the first degree of my irreducible quadratic factor. And then I'm going to need another one for the second degree of my irreducible quadratic factor. So what I'm trying to say here is my original fraction, that beast, oops, that should be a cubed. All right, here we go. I need a fraction for the linear, a over x, right? That's linear because x is to the first power. This is quadratic, so I need a fraction for the first degree of that. Then I need a different fraction. What are we up to? D? Dx plus e for its second power. Okay? And then, like every example we've done, I want to knock out fractions. So I'm going to multiply by that LCD of x squared plus 1 squared. And since this is such a beast, I'm actually going to write all of this out so that you can see what's happening. So I'm going to multiply that LCD to the left side. And this is going to take me a minute to write out. And if you're to the point where you feel like you can skip this step because you see what cancels, and good for you, go ahead and just kind of scooch down the video. Right? And if you're not there yet, no, that's totally okay too. Right? Fractions are tricky. All right, let me distribute this LCD to every single term in here. All right, here we go. Let's see what cancels. So by design, these denominators cancel. Here the x will cancel, and I'm left with this x squared plus 1 squared. Here, a power of x squared plus 1 will cancel, and then here both of them will cancel. So I'm going to see what's left and write that up. So I'm going to have x to the fourth plus x cubed plus x squared minus x plus 1. That's going to be equal to a times x squared plus 1 squared. All right, and then I'm going to have bx plus c times x squared plus 1, and then x times dx plus e. And I could have written these in any order. All right, so what I can do is I can plug in specific values of x if I want, or I can try and set up a system of equations. And personally, when I look at these factors, nothing really cancels. I could maybe, if I plugged in x equaling 0, I could get a couple of these to disappear. That might be helpful. And maybe I'd try x equaling 1 and x equaling -1, but I'd have to plug in a lot of x values. And that's a totally viable option, but I'm going to try and set up a system of equations. I don't know if it'll be faster, but I'm going to try it. So that means I got to multiply all of this out. So x to the fourth plus x cubed plus x squared minus x plus 1. All right. So imagine this term, right? X squared plus 1 squared. That's x squared plus 1 times x squared plus 1, right? So I'm ultimately going to have a times, or if I FOIL this, x squared, x to the fourth. Outer is x squared, inner is x squared, so I have 2x squareds plus a 1. All right, I'm going to send this x. I'm going to go ahead and send that through here. I'm going to distribute it this way. I also could have distributed the other way. You can multiply in any order. But if I distribute that x through, now I'm looking at x cubed plus x. All right, I'm also going to distribute this x through. So this is going to be dx squared plus ex. All right, so let me do another iteration of this and get everything multiplied out so I can start lining up terms. All right, what do we have? Ax to the fourth, 2ax squared plus an a. When I FOIL this, okay, bx times x cubed is going to be bx to the fourth. Outer, bx times x, bx squared. C times x cubed for inner. And last is cx, and then we've got dx squared plus ex. Okay, let's start doing this. Here's an x to the fourth, x to the fourth, x to the fourth. So my first equation, I'm going to get 1 equaling a plus b. Okay, let's look at cubes. All right, there's a cube. Here's a cube. So when I take a look at the cubes, I only have one cubic term on the right side and I have a 1 here. So c is equal to 1. Great. There's one of my letters right out the gate. Let's look at the x squared. I got x squared, 2ax squared, bx squared, and I think that's gonna stop that for me. So let me go ahead, put a little separation bar. I've got 1 equaling 2a plus b. So I can see already I have a system of equations with a and b, right? A 2 by 2. I could solve for that, but let's see if anything else kind of pops out. All right, I've done the x squared. So let me box the linears. So negative x, cx, ex, right? So when I start to put that together, right, I have negative 1 equaling c plus e, all right? And then let me look at the constants. So I'm just going to put a little bubble because I'm kind of running out of symbols. There's that, and I can see an a. Oh, I'm also noticing I potentially made a typo. Okay, so I'm going to put this around here. I can see a equals 1, but I'm noticing as I go through my terms, I missed this x squared, right? So that was on the squared, so that was the circled one. So let me circle this. So on the circled ones, we should have had 1 equaling 2a plus b, let's do it, plus d. Ooh, glad I found that. But that's why this is a lot of terms to manage. It's good to just take a look. Did I get everything on this side? Okay, but I have a equaling 1. That's huge. That's gonna help me with all of this. So if a is 1, right? Let's go back to this equation. If a is 1, all right, 1 is equal to 1 plus b. So that's telling me b is 0 because I can subtract 1 from both sides. So I have c, I have a and b. Okay, so now if I have a and b, I think I can find d here. So 1 would be equal to 2a, which is 2, plus b, which is 0, plus d. So if I move the 2 over, I'm going to get d is equal to negative 1. All right? And then I know what c is. C is 1, so I'm going to substitute that in here. I have negative 1 equaling 1 plus e. So that's going to tell me e is negative 2. So when I get all of that done, I do have my 5 letters, right? So this is going to be 1 over x, right? B, I actually have, this is going to be 0x here, plus c. C was 1. So this is going to be 1 over x squared plus 1. This is going to be negative x minus 2 over x squared plus 1 squared. So I'm going to scooch this up and then write all of that out. So let me move this up so we can see this. I'll put some separation here. All right, so my original fraction, right, we had x to the fourth plus x cubed plus x squared minus x plus 1 over, that should be x times x squared plus 1 squared. Okay, that should be equal to, and we can't see what I'm pointing to, but a over x, so a is 1 over x. All right, bx plus c would be 1 over x squared plus 1. Dx, right, so negative x plus e minus 2 over x squared plus 1 squared. Right, and since I can see, for me personally, I see a negative on both terms here. So what I'm going to do is I'm actually going to take the negative out of both of those, and I'm going to put the subtraction sign here. Because this subtraction would apply to the x and the 2, So if I distribute that negative, I would get negative x minus 2. All right, so I just want you to, and I'll put a little note here, right? Just so you're seeing where it's coming from. If I had a negative of x plus 2, that is negative x minus 2. So I'm just going to move the subtraction sign out in front because it looks a little cleaner. I don't have as many negative symbols. So, and I'll put my little therefore so I seem fancy. And that is my answer to this beast of a partial fraction problem. All right, thanks so much, everyone. Bye.